Hello guys, welcome to Lead Electrical Academy. So in this class we will discuss three-phase full converter, three-phase full converter which is fed from DC series motor. DC series motor. So for this, as it is a full converter, as it name itself means, full converter means we are considering only the thyristors. So in the upper leg connection we will consider 3 thyristors. This is the upper leg, and in the lower leg also we are considering 3 thyristors. So in case of semi converter, in the lower leg we have considered the diodes, but in case of full converter we are considering thyristors in the both the legs, and the parallel RA and RF will be taken. RA is known as armature resistance and RF is the field resistance. L is the armature inductance and E is the back EMF, motor back EMF. So this is a construction of 3-phase full converter DC series motor. So for this, when alpha equal to 0 degrees, so when alpha equal to 0 degrees, we will consider here, when alpha equal to 0 degrees, thyristor T1 will be triggered. Thyristor T1 will be triggered. So the thyristor T1 will be triggered at positive voltage. At positive voltage appears at 30 degrees, and T2 will be negative. No, T2 will be in negative position, negative voltage. So it can appears at 90 degrees and appears at 90 degrees in the waveform. 90 degrees in the waveform. And similarly T3, T4 and T5 and T6 can be triggered at 150 degrees and 210 degrees, 270 degrees as well as 330 degrees respectively. So the conduction sequence of thyristors can be shown here. I will show it. So if you observe in the waveform, T1 will be triggered at 30 degrees. So T1 will be triggered at 30 degrees and T2 will be triggered at 90 degrees. So this is 90 degrees, and T3 can be triggered at 150 degrees, and T4 can be triggered at 210 degrees, and T6 can be triggered at 330, and T5 can be triggered at 270 degrees. So this is the waveforms. So the T1, T3 and T5 will belongs to positive group. T2, T4 and T6 can be belongs to negative group. So this is a conduction sequence of thyristors of upper and lower leg connection. So here each SCR or thyristor, each SCR will conduct for 120 degrees. Each SCR will conduct for 120 degrees at any time. Two SCRs, one from positive and one from negative will be conducted. So from each group 2 thyristors will be conducted, from one from positive group and another from negative group. 2 thyristors will conduct together. So if we consider these pairs of thyristors, T1 and T2 and T2 and T3 and T3 and T4, T4 and T5 and T5 and T6, again T6 and T1 this is the phase sequence of thyristors. So first T1 and T2 will conduct, next T3 and T4, next T4 and T5 and T5 and T6, again T6 and T1. This will repeats in the sequence. So if we consider for alpha equal to 45 degrees, if we see for alpha equal to 45 degrees here, the conduction sequence from T1 to T6 can be indicated. So T1 will be triggered at 30 degrees. If T1 will be triggered at 30 degrees, so I will show here. T1 can be triggered at omega t equal to 30 degrees. So 30 plus 45. So it will be T1 will be conducts for 75 degrees, and T2 will conducts for omega t equal to 90 plus 45. 90 plus 45. So it will conduct for 135 degrees, and this will continues. So first, it is easier to represent voltage and current waveforms. We have to consider each thyristor conducts for 120 degrees. So T1 is triggered, reverse biases T5 will be turned off. When T1 is triggered, T5 will be turned off. T5 will be turned off condition, and T1 is turned on. T6 will be already conducting. T1 is in on condition. T6 is already conducting. So it is connected to A, which is connected to A point, and T6 is connected to B. So the voltage VAB appears across 1.5 volts per omega pm. So here, if we see this waveform, the voltage appears across the load varies from 1.5 voltage per cycle to 0. So 1.5 voltage to 0 it will be varies. So the sequence of triggered is continued for remaining thyristors also. So for 90 degrees the load voltage will be symmetrical. So here I will drawing the for 90 degrees the load voltage will be symmetrical. Load voltage will be symmetrical. About reference line omega t. So the average value will be 0 volts for 90 degrees, and for alpha equal to 150 degrees, T1 is triggered at 120 degrees, and T2 will be triggered at 270 degrees, and this will continues. So on it will be continuous for alpha equal to 150 degrees. So the average output voltage can be reversed. The average output voltage can be reversed polarity. So the average output voltage can be reversed polarity. So what is mean by this reversed polarity? Reversed polarity means DC source, the DC source is delivering power, to AC source. DC source is delivering power to AC source. So this is called as line commutated inverter. Line commutated inverter operation. Of three-phase full converter bridge. So the alpha equal to 90 degrees we can be shown in the graph for alpha equal to 90 degrees also. So the alpha equal to 90 degrees to 180 degrees it can act as a inverter for alpha equal to 90 degrees to 180 degrees, it can act as a line commutated inverter and delivering power to DC source to AC source. So it can be noted that direction of both converter and inverter depends on both converter and inverter operation. Converter and inverter operation depends on voltage. Due to the voltage, the converter and inverter operation will be varies. So this will be the for less than 90 degrees it can act as a converter. From greater than 90 degrees it can act as a the line commutated inverter. So this is the operation of full converter DC series motor. Thank you guys. We will meet in next class.